Good morning, friends. As we know, we are all doing some problems on pressure in fluids from Concise Physics class 9. And this problem states, it's a very simple problem. Like if you have followed my other 8 problems, this is very simple. The areas of pistons in an hydraulic machine are 5 centimeter square and 625 centimeter square. What force on the smaller piston will support a load of 1250 Newton on the larger piston? And the second part, state any assumptions which you make in your calculations. Okay, so we can clearly see this picture in here. If we try to mark, this piston A as the smaller piston with an cross section area of 5 centimeters square, and piston B as the bigger one with an area of 625 centimeters square. So this area is this cross section area. This one, the one I'm drawing in blue, is 5 centimeters square, and this cross section area, this
green
is, well, yeah, the green, the one I'm drawing in green, is 625 centimeters square. Now, like asking if I'm putting if I have to balance a load that is on piston B, a load on piston B, which if it's kind of a load or some weights, that is how much this load is given as 1250 Newton. So normally if we put this load, this will try to go down, so this will try to go up, piston A, but then it is asking what kind of weight, what is this weight that I have to put here so that it balances, so that the piston A out here does not go up and it remains here where it is, so it doesn't go up, kind of a thing. So that is it does not go up. So what kind of weight, what is this weight that I have to put in, so we know by Pascal's law, like pressure is equal to force by area. That's not from Pascal's law, that's like we know this, right, in previous chapters from previous classes. What we know from Pascal's law is pressure everywhere is the same. Like here, this P1 and this P2 are the same. So whatever the pressure at this point here will be have to be the same at this point. So if I say pressure on piston A is P1 and pressure on piston B is P2, or PA and PB, so like PA is equal to PB. So what is PA? PA is nothing but force that or weight they have to give in piston A by its area, and in PB, then piston B is nothing but force that I have to support, that is this 1250 Newton force that I have to support by area of the and from the given equations we know that what are the things that is given is like see, the areas are in centimeter square. We have to convert it into meter square, so it's easy, we have been done. So we don't know what is the balancing weight on A, so put it at FA, but we don't know how, what is the area, cross section area of piston A, 5 centimeter square into 10 to the power minus 4 meter square, which is equal to nothing but 1250, that's given in Newton, by 625 into 10 to the power minus 4. So if we use the help of the next page, and if you just write the same thing one more time, like for example, FA by 5 into 10 to the power minus 4 is equal to 1250 by 625 into 10 to the power minus 4. So these two things gets cancelled out, like the same on both the sides gets cancelled out. So what is remaining is FA, that is equal to 1250, and as a cross multiplication this goes up, okay, into 5 by 625. Now if you divide both this thing with 5, and if you try to divide this 625 by 5, is like 1. It's like, I'll do it for you if it is difficult. It's very simple. It's like 125, so 1 out here. This is like 5, so the remainder is 1. We get 2. We put 2 out here, so that's 10. There's another 2, and then 5, so it's like 125. So it's like 125. Now this 125 and this thing gets cuts out, and it becomes, that's 10. So it's like so FA, that is the balancing force that you need to put on piston A, is nothing but 10 Newton. This is the answer. So what you came to know is like, to balance this 1250 Newton placed on piston B, we just need what? 10 Newton. Can you imagine? Just a small load to balance it. Such a huge load, almost 125 times, because you have reduced the cross-section area of piston A also 125 times less. So what are the assumptions that we take? We take there's no friction, there's no loss of loss of energy, or loss of force, or loss of this pressure due to friction, and there is no leakage, like there is that liquid doesn't fall off. No, it does not happen. So the entire pressure, whatever I'm getting out here, is getting transmitted through this liquid everywhere. There is no loss in thing because of the friction. We have seen that this fluid, the brake fluid or the piston fluids, are in fluid, so it's like a bit of greasy and oily. So we know the friction, like if you put some oil in our hand, coconut oil or something, try to hold some steel rod or something, it slides, it slips, right? That means it has very less friction. So obviously the fluid passes through this iron pipe or SS pipe, so the friction is very less. So we can ignore friction out here, and we know that just like a perfect solid, there is no holes in that, so that the liquid doesn't flow off. So that are the two assumptions we take during this kind of a problem. Anyways, the problem is very easy. It's just another Pascal's law problem that we have done. Thank you, friends, and if you have any doubts regarding this or any other problems that you are facing in physics or in any of the classes, you can just post that problem, take a snap of that, and send us in our Facebook or something like that of 21st Century Learning. That's our Facebook, that's our YouTube account, and we will obviously, definitely within next 24 hours we will be giving you a video solution which will explain each and every concept that's required to solve the problem, basic understanding of the problem, and obviously the detailed diagram of the problem. Thank you.